Welcome everyone to the Journey to Mars NASAARES webinar. My name is Paige Graff and I'm on the line here with Suzanne Foxworth as well as our featured speaker Doug Ming. We'd like to welcome all of you for joining us today, and we are so excited to bring you this webinar, The Journey to Mars. We do have participants literally from all across the nation. So we've got about 18 states plus Mexico that have registered to participate, and we've got students spanning from grades K through 12. This will be targeted to a middle school level, so hopefully we can make sure that your students in the classroom can really get the most out of this, because this will be a very exciting presentation. Now, this presentation wouldn't be occurring if it weren't for our featured speaker, Doug Ming. Doug Ming is going to introduce himself here in just a moment. He is at the NASA Johnson Space Center here in Houston, Texas, and that's where we're broadcasting from Houston, Texas, and he is part of the Astromaterials Research and Exploration Science Division here at the NASA Johnson Space Center. So without further ado, I want to turn things over to Dr. Doug Ming so that he can introduce himself and so that he can share his camera so that you can all see him, hear him, and learn about the journey to Mars. So Doug, with that, I'm going to turn things over to you. If you want to share your screen, I'll confirm that we can see and hear you.
Can you hear me, Paige?
I can certainly hear you. Yes, I certainly can. And I'm going to see if I can see you here. Let's see. And it looks like we can see you as well. So welcome, Doug. Thanks so much for joining us.
Outstanding. Thank you, Paige. First of all, I want to thank all of you for joining me here today on my favorite planet, Mars. What I hope to do here this morning, and for some of you, afternoon for others, is to give you some information about the planet, to give you the tools that you may need to help you design projects that will hopefully someday send humans there. So I'm hoping that when we get done with this project, this program today, that you'll have some key essential knowledge about the planet, as well as what it takes to get humans to the surface of Mars. But first of all, I'm going to just spend a minute or two talking about how I ended up working for NASA. I grew up in a little bitty town in eastern Colorado where we primarily did farming to make our daily living. I was working on wheat farms, corn farms. We did a lot of cattle. So that was my upbringing in my grade school through high school years. I did pretty well in math and science, and did well enough that I got accepted into school at Colorado State University, where I then got a degree in agronomy. And those of you that know what agronomy is, it's the study of soil and plants to help in agriculture. I went on to get a master's degree at Colorado State University in soil science, and when I finished there, I was again lucky enough to get a doctorate at Texas A&M University, where I also did soil science. During my final year, when I was at Texas A&M University, two scientists from NASA showed up at the department one day, and they were asking me and some of the other professors, could we grow plants in lunar materials? I never even thought about working for NASA, but after talking to those two NASA scientists, I began to think, wow, why not? Why can I not go work at NASA? So I approached them and said, I'm really interested. Is there some way I can come to NASA and help you determine if we could grow plants on the moon? I was fortunate enough to get a postdoctoral fellowship at NASA Johnson Space Center, and 2 years later, I was hired on to work for NASA. Now, for the first 15 years of my career, I worked on an area called Advanced Life Support Systems. These are the systems that keep the crew alive for long periods of time, and we were primarily targeting having life support systems on the moon and Mars. So you can well imagine how extensive these systems were, and we were developing systems using plants. We were developing systems using brute force, power to convert all the waste back into usable constituents. And so that was my first 15 years. And then about 15 years ago, I started working on the planet Mars. And boy, has it been a thrill to be on the planet. I've been lucky enough to be a science team member on 5 missions to the surface. Spirit and Opportunity launched in 2003 and landed on Mars in 2004. And the Mars Phoenix Scout mission landed in 2008. And one of the ones I'll talk about a lot today is the current rover on Mars, Curiosity. Curiosity landed in August of 2012, is currently sending incredible data sets back from the red planet, telling us about conditions and how we might use that information to help humans one day go to the surface. So, you know, somebody has to drive rovers on Mars, so I said, why not me? But I also must tell you all that it takes a lot of solid foundation in math and sciences, and it's just a will to do it. And that's exactly what I had to do to get to where I am today. But anyhow, I'm going to mainly focus on Mars, and I want to talk about some of the results that I have been actively obtaining on the surface that change the way we look at the planet. Now, we have a whole bunch of rovers and landers and orbiters that have gone to Mars in the past 15, 20 years. This just shows some of those. There are others that are currently about ready to launch to Mars, ones that we hope to launch in the next couple of years. But Mars is the focus. Now, why Mars? Well, Mars is probably the most Earth-like body near Earth that we can get to in a relatively short time. When I say relatively short, it still takes anywhere from 7 to 11 months, depending on how the Earth and Mars line up, to get a spacecraft there. So I'm going to ask your first question here. And if you're going to go to Mars, you have to know about the conditions on the planet. So go ahead and let's answer a few of these Mars facts. Some of you, I wouldn't know them unless I went and looked them up, like the diameter of Mars. But let's see what you know out there and see if you're ready to start planning to go to Mars or not.
All right, so in the chat window, if you know something about a Mars day, you can write in the number 2 and what you know, and we'll stand by and start reading some answers. If you don't know anything, you can let us know that too. So let's see what comes in. So Thompson Middle School says that the seasons are twice as long on Mars as Earth. So that's one piece of information. And Thompson Middle School is there in Centerville, Georgia. Let's see what else we might get. What kind of polling is get an idea of what you know? So Smith Elementary, our group in Delaware, says it's close to the size of Earth. Wait, that was Evansville, and they're in Indiana. Smith Elementary said a day is about 23 hours. JCTMS says it's about half the size of Earth, and a day is a couple of hours longer than the day on Earth. Perry Innovation Center, they're our group in Michigan, I believe, are saying temperatures maybe about -80 to 260 degrees, so a pretty wide span there. We'll see how close they are to being correct there as well. We have some other groups. Peavine Elementary in Nevada says a Mars day. Something about a Mars day in November. There's a Mars day November 4th. Perhaps it's a day of celebration. Thompson Middle School is also mentioning some things about sandstorms. JCTMS in Kentucky says the year is twice as long as ours. Perry Innovation Center says it's about 1/3 the gravity of Earth. Murfreesboro mentions that a day is a little longer than a day on Earth. Let's see, Peavine says 27.5 hours long for a day. Gravity's less on Earth. That comes from Smith Elementary. Gifford Middle School is mentioning that the atmosphere is thin, so it might have been swept away, they're suggesting, by solar winds. 687 days in a year. That comes from Perry Innovation Center. NMMSH in New Mexico says very little atmosphere, mainly CO2. JCTMS is less gravity and much colder because it's further away from the sun. So we've got some really great information there, Doug, and some things we might want to refine a little bit, but overall, great answers.
Absolutely. I tell you what, for just questions like this, just off the cuff, you did incredibly well. And so you've got the first step on determining what systems you'll need to go to Mars if you understand the conditions. Well, let's just look at the conditions here and some of the things about Mars very quickly. The diameter is 53% of that of the Earth. So those of you that said that a little bit smaller than Earth were absolutely right. The Mars day is called a sol on Mars. So when I say sol the rest of this presentation, I'll be talking about 1 day on Mars, and it's 24 hours and 37 minutes long. So you would be staying up 37 extra minutes every day on Mars if you lived on Mars. A Mars year is almost twice as long as an Earth year to go around good old our solar system sun, 687 days. And the seasons are absolutely right. There are 4 seasons, and they are twice as long as Earth seasons. So that was a great answer. And the reason there are seasons, because Mars is tilted very much the same way that Earth is to give those particular seasons. The atmosphere, every one of you got this right. It's much less than that on Earth. About 95% of the 1% of Earth is carbon dioxide, a little nitrogen, and yes, there is water vapor in the Martian atmosphere as well. Great answer. And again, the gravity on Mars is 1/3 of that at Earth. Another great answer. And the temperature ranges are about minus 220 degrees Fahrenheit, a little cooler than we might have thought, up to about 68 degrees Fahrenheit, probably the temperature that you are experiencing right now in your classroom. So great answers. This will give you the information about Mars that should help you start planning for designing colonies, outposts, whatever you're going to be doing in your classroom. Now, the one thing I love to tell people about, and I live here in the state of Texas, and in Texas we say everything's bigger in Texas. Well, not quite so fast, Texas, because really things are larger on Mars. For example, Valley Marineris, if it were here on planet Earth, would stretch from the western coast of the United States all the way to the eastern coast of the United States. And it's about 7 kilometers deep. It's much deeper than the Grand Canyon, so you can well imagine how massive this valley is. And then it has the largest volcano in the solar system. Olympus Mons is about 24 kilometers high, and by comparison, the largest volcano on planet Earth is Mauna Loa in Hawaii. It is only 9 kilometers high, so you can see how large the features are on the planet. Mars is also what we call a basaltic planet. And basalts are created by volcanic activity, where if you see those wonderful features in Hawaii that's flowing lava on the surface, that is basalt. The composition of that is basalt. So all of Mars is a basaltic planet. The other thing, one of your answers was about dust. Yes, Mars has incredible dust storms. In fact, here are images taken by the Hubble Space Telescope that was taken in 2001 in June and September. The one on the left in this picture shows Mars pretty clear. You can see the polar caps, you can see some clouds, you can see the surface of Mars, and then the surface is almost completely engulfed by dust that has been lifted up in the atmosphere by the winds of Mars. Now here's another great picture. This was from the Opportunity lander. This is in a place we call Meridiani Plenum, where you can see on Sol 1205, it was pretty dusty. You can see here only about 39% of the light was getting through the atmosphere down to the rover. And then in July, on Sol 1235, only about 1% of the light was getting down through the atmosphere. So you can see this might be a real problem, particularly if you have solar-powered vehicles. And true enough, here are images of the solar arrays on the Opportunity rover. On the left was right after we landed, really clean solar panels, and you can see the dust on the right on the rover's panels, and this significantly reduced the power that we were able to generate by the rover. Now, wind can be bad. Lifts up dust, covers our potentially all of our vehicles, but there are also things called dust devils. Here are some dust devils in Gusev crater. This is where the Spirit rover landed back in 2004, and these look like dust devils in eastern Colorado, out there in New Mexico. You folks in Arizona, you see a lot of these things, I'm sure. We see these dust devils quite frequently on Mars. They're a common effect. Now, if this hit the rover, you might think that would be a bad thing, but it's not. These are higher winds. When they hit the rover, and we have numerous instances where they have hit the rover, instead of putting dust on the solar panels, they actually clean the solar panels, and it significantly increases our power the rover can generate. So wind can be bad, wind can be good. Now, one thing I want to talk about, and this is somewhat of a misconception on Mars, is that the winds on Mars are horrible. The winds are typically less than about 20 meters per second or 45 miles per hour. Now, the thing that you got to take into consideration here is that Mars has 1% as dense of an atmosphere as Earth. Therefore, because of that, the winds do not have as much dynamic force on you because of the fact that you do not have as dense of an atmosphere. So therefore, if you did have hurricane force winds, where along the coast, as all of us know that are along the southern portion of the U.S. and the eastern coast of the United States, that when we get hit with hurricane force winds, they're horrible. They tear things down. On Mars, it would just simply feel like a slight breeze. Now, we are constantly taking atmospheric measurements on our rovers and landers. This is a particular instance on the Phoenix where we were able to do things such as wind, temperature, a few feet off the ground, right at the ground. We were looking up in the atmosphere. We were looking at how much dust was in the atmosphere. We were measuring temperatures down in the subsurface. And so we were able to give a Martian weather report every day we were operating every sol on Mars. And here's just an example that now this particular lander was about 70 degrees northern latitude. It was pretty close to the northern pole on Mars. The maximum temperature that day, minus 30 degrees C. That's minus 22. Those of you in the north, Minnesota and those areas are familiar with these temperatures, but minus 112 that day, that's pretty darn cold. So if you're designing systems, you've got to take in the consideration of the very large temperature swings in a day, and very cold temperatures is almost certain going to happen certain times of the year. On the Curiosity rover that's on the surface today, we are recording again the atmospheric conditions. What is the temperature? What is the pressure? What are the winds? What are the speeds? And on this particular, these two sols, you can see that the temperatures were about minus 66 to minus 77 degrees air temperature and the temperature right at the ground. Now, I'm not going to get into the details of why those two are different, but you might go back and do a little research in the classroom to determine why there's a difference between the air temperature and the ground temperature. We also know that water vapor we were talking about in the atmosphere can actually condense out and frost can form at the surface. So it's quite common to see frost at some of the landers. And these are the Viking landers from back in the 1970s. 1976 we took this picture. And just to give you an idea, this is probably some of the most prevalent ice that we've seen on the surface of any of our landers or rovers. Now, we've landed a variety of different sites on the planet. This shows those various sites we've landed. And you see the Phoenix landing site up here at the very top. This is where we landed near the North Pole. That's why it was so cold, minus 122 degrees Fahrenheit. And we're getting ready to launch in the next couple months another lander called In-Situ that will land pretty close to Curiosity, where we landed back in 2012. So these are the data collectors that have helped us really understand the planet. Now, with that data in mind, we can then start thinking about where would we send humans. So now I'm going to transition into what will we need to do in order to keep a human crew alive for long periods of time. NASA's looked at this. We selected about 50 landing sites as a potential place we would go. And these sites were chosen on science. Where can we do the best science? Also, where might we be able to get resources? And I'm going to talk a little bit about resources here in the next few slides to give you an idea about the types of things that NASA hopes to use on the planet to help us live there. So now, this is let's just see what you think about what it would need to live and survive on Mars. So in the chat window, let's go ahead and provide some answers about what do you got to worry about? What are the big things you've got to absolutely have to keep a crew member alive for not just a few days, but potentially for years?
All right, so we'll see. We've got some answers coming in. P-Vine is saying you're going to need oxygen, water. Smith agrees you're going to need water, and they're in Delaware. P-Vine is in Nevada. Thompson Middle School says food, water, air, shelter, energy. Strong shelter from Thompson Middle School. Evansville Day School says food. Let's see, NMMSH says energy. P-Vine also mentions about a water reclaimer. And JCTMS in Kentucky, food, water, oxygen, spacesuits. P-Vine also adds in a safe shelter, as does Smith Elementary. Athens Intermediate, speaking of these cold temperatures, they're saying winter clothes. And Thompson Middle School agrees clothing will be important. Meadow Creek adds a very interesting thing, and they're from Texas, radiation protection. Thompson Middle School solar power, transportation from Perry Innovation Center. JCTMS is mentioning shelter and protection. Calais Elementary School in Maine says water, food, oxygen, warm clothing, exercise stuff. Aerospace Academy in Mexico says food, oxygen, and water. Thompson mentions medication. Shelter from Calais. Perry Innovation Center says communication. And we have another information here on medical and first aid. Athens Intermediate from Georgia says nutrients and medicine and tools. And Smith is adding in soil if we want to plant plants. And P-Vine says spacesuits, air filter, solar panels, pressurized shelter to keep people safe. Meadow Creek adds waste treatment plan, strong suits, oh my goodness, clothing, entertainment, radio transmission from JCTMS. NMMSH also adds in tunneling tools. Gifford Middle School mentions a 3D printer to make tools, and Smith Elementary adds in waste disposal. Oh my goodness, there's so many things here, Doug. What do you think?
Well, if we would take your lists and put them together, I don't think there's probably anything uncovered. I think you did an incredible job. You've defined the things that NASA's worried about. But I'm going to focus on just a few of the basics. But you're absolutely right. We're going to need all kinds of things. Medicine, entertainment, the 3D printer. I love it. We are looking at how to do that right now with materials from Mars, how we could use the materials at the surface and a 3D printer to make things on the surface. So these are all fantastic answers. Communication, absolutely. But what I want to talk about and focus on is the things that will most likely be the most essential things, and that is water, air, food, and shelter and power. And almost every one of you nailed those 5 various areas. So first of all, food. You know, I have always told folks that that's probably one of the most important aspects of going to Mars. Not only do you need the food, but if I was going to Mars, I would love to have the capability to grow a tomato and see this big, red, juicy tomato after being on the surface for 300 days. Psychologically, I think that plants are going to be essential for not only the food, but for the psychological well-being of our crew member, so they don't go crazy. But anyhow, why would we grow plants on Mars? Food, fresh air, clean water. Plants are fun to grow too, as I was just mentioning. So the first thing, some of you made a notion that maybe we would bring soil from Mars. Maybe we would just use materials from Mars. So this particular question is, the plants need essential nutrients or elements. And in the next chat, let's go ahead and put in what those elements are, and I'll give you a hint. There are 16 essential plant nutrients or elements.
So let's see what you think in terms of what some of those nutrients or elements are. I know for me this would be a tough one, but we got some smart cookies out there, so we'll see what they say. So Gifford says bacterium, nitrogen, phosphorus. Let's see what else we get. And Gifford is our group from Vero Beach, Florida. Thompson Middle School in Georgia says iron. So that's another potential. We'll see what else comes out there. Athens says calcium. Perry Innovation Center says sunlight. Smith from Delaware says water and light. Now think about elements and nutrients. Evansville Day School says water, soil, CO2, minerals, and potentially even humus. Gifford Middle School says potassium. Thompson Middle School adds in iron. JCTMS has added in phosphorus, nitrogen, sulfur. Perry Innovation Center added in fertilized soil. Thompson Middle School, light energy, CO2, nutrients from the soil, ozone, water. Thompson Middle School also added in carbon. Meadow Creek mentions a light source and CO2. And Perry Innovation Center says oxygen. So we've gotten some of these potential elements and nutrients here. This is a tough question. And Aerospace Academy from Mexico says we'd also need a little bit of UV protection. And Mohansic Elementary School says some oxygen, minerals, and farming materials. So how about some of these specifics, Doug? What specific elements, some of which were mentioned?
Well, first of all, I counted 9 of the elements. You got 9 of the 16. Fantastic on getting that, because probably you almost have to get a PhD in soil science like me to understand all 16 of those, or at least a bachelor's degree in agronomy to understand what those are. But you got 9 of them. Fantastic. And you added some absolutely essential things that you need for plants to grow. UV protection, sunlight, an atmosphere to grow them in, the carbon dioxide. Those are essential for the plants to grow in. So the 16 elements are listed here. We have what we have called the major nutrients or macronutrients: oxygen, carbon, hydrogen, nitrogen, phosphorus, potassium, calcium, and magnesium, and sulfur. You got all those, I think, except magnesium, so well done on that. And then the micronutrients, you just need really small amounts of these nutrients for plant growth. You all got iron, that was a great one. But the ones that you probably don't know much about also are essential for plants: zinc, molybdenum, chlorine, boron, copper, and manganese. Now, you see check marks up here next to every one of these elements. And the reason that is, as we have identified all 16 elements in the materials on the surface. So the loose, unconsolidated regolith or soil that's at the surface of Mars has all of these in them. So we know that the elements needed to grow plants are on Mars. The question is, how do we then modify that material? Maybe we add humus. Maybe we add something to it to give it a little bit better structure, better ability to provide nutrients. Maybe you add a little fertilizer to it. That's absolutely something we're looking at, but you've got the basics here, and that you understand now that these things are needed to grow plants. Okay, now there's also something that NASA's looked at. We looked at what plants should we grow on a moon or a Mars base to help not only provide food, but also regenerate the carbon dioxide into oxygen, as well as to maybe recycle some of the water. We can feed plants wastewater, and it can actually regenerate that water through a process called evapotranspiration to produce that. But I'm not going to go through these, but these 14 plants have been deemed as the most likely plants we would take with us to Mars. Now, NASA has looked at over the years ways to grow plants, and these are just some examples. On the top here, these are in plant growth chambers at the Johnson Space Center where we have grown plants. We've even had an experiment back in the 1990s where we placed a human crew member inside a plant growth chamber, and they survived for 15 days based upon the oxygen produced by the plants. So we know it works. Also, we are growing plants in space. These were both done on the International Space Station. You can see wheat growing here and a mustard plant growing here, just to see if they can survive in microgravity. And you can well imagine this would be a totally different presentation to talk about growing plants in microgravity at the International Space Station, because that's very different than Mars, where we have at least some gravity, although it be 1/3 of that here on planet Earth. So the question is, how might we grow plants on Mars? There are 2 different mechanisms that we have looked at. Hydroponics, and you can see here on the left that this particular lettuce is growing in water. Most of you have probably seen hydroponics. And then the most traditional way that we're all very aware of is growing those plants in soils. And in fact, those of you who've seen The Martian will recognize this particular scene where astronaut Mark Watney is growing potatoes in materials that he got off of the surface of Mars, brought them in the chamber, modify it with some fertilizer, and those of you who watch the show know how he did this. And actually, if I was in his position, I would have done exactly the same thing. So now let's ask another question. We got hydroponics, we got soils. Which approach would you use on Mars and why?
And the why part of that is ever so important, as well as just how you think you would approach growing plants. So I'm looking forward to see the types of answers we're going to get on this one. So I'll stand by and see what we get. NMMSH says both, and I'm looking for a why added to that. The thoughts and the rationale behind some of these things are almost as important as what you might choose as a good approach. So we'll see what else we have come in. Meadow Creek says soil because water will be a precious resource. Evansville says hydroponics because the soil lacks some nutrients, although we've mentioned that it does have quite a few of those. Smith Elementary adds in hydroponics. JCTMS says soil is better because there's not enough water to dedicate to plants. Gifford Middle School says you need to bring bacteria and organic material to use soil. Thompson Middle School says soils would be a better approach because it would be more difficult to get water to Mars and the location of the plants. Now, Aerospace Academy in Mexico says vega hydroponics. Kruger Elementary says Martian soil. We would have to take water with us. Aerospace Academy does also include there the hydroponics idea. Synergy Quantum Academy says prefer soil due to the shortage of available water, but the availability of Martian soil. Evansville Day School says maybe a combo, Martian soil and human waste, perhaps for fertilization. Peavine says hydroponics might be better because the elements are able to dissolve in water. So we actually have a little bit of a mix. Some say a combo, some say both. Some lean towards hydroponics, and Thompson Middle School says hydroponics because we need water and food. So, Doug, is there even a right answer on this?
Yeah, this was a little bit of a trick question. There is not a right answer. We could do it by hydroponics and soils, and I absolutely agree with those of you saying a combination, and here's why. Soils are better suited for some crops. Plants that have tubers that grow on the ground and produce large fruits underneath the surface, like potatoes, radishes, those things do better in soils than they do in water. And on the other hand, you can get much better growth, really rapid growth in hydroponic systems, like with wheat, for example. We found that you can have incredible yields, providing, as many of you correctly stated, the exact nutrients needed for the plant. So it's going to be, I think, a combination. It's a complicated system. There's no right answer here, but you all did fantastic on answering it. So now, water. The one thing we probably won't do is we probably will not take all the water with us. We might take some water when we first go there for the very first time, but NASA is planning on extracting water from Martian surface materials, or maybe in the atmosphere, and I want to talk about where we might get that water. First of all, there's water at the Mars poles. We know that. We see it through our telescopes. We've flown over it. We know absolutely that water is frozen on the poles just like here on planet Earth. So we could go to the poles, although you might have to think about how you would get that because remember, it is cold at the poles. There's also water right under the surface. When we landed with the Phoenix lander up about, 3/4 of the way to the North Pole, when we landed, we had the retro rockets blasting out the surface materials and we exposed pure ice under the surface regolith. So we know that a little bit further down from the poles, there's water just right under the surface. So you can well imagine that could be extracted. You could have a heating device that goes down, melts that water, brings it back into your water processing system, and bam, you've got water. Now this just shows a map of the hydrogen on the surface. Blue here that you see near the poles, both the north and the south poles, and the pink are high concentrations of hydrogen that relate to very high concentrations of water, where you have almost 100% water at the poles. So this shows you where the water is. So there's not as much water around the equator that is just pure water. So that could be a problem because most of our landing systems can only land around the equatorial region, and it's very difficult due to the conditions that we see near the poles to put a crew member there. We also know there's evidence of past water on Mars, and this is one of the things I've been studying very extensively for the past 15 years, is how can we extract information from the geology. Here you can see the surface features of Mars, and understand how water once was present on the surface. And here is a elevation map. Blue here is low, red is high. You can see this blue, sinuous looking, curving looking thing that looks like it could be the Mississippi River, right? How it meanders up through the middle of the country and it's depositing water in this particular crater. So there's a lot of evidence for valley networks, we call them, in geology terms, where water is flowing down into a low and creating these valleys, just like here on good old planet Earth. We also know that there was ancient lakes. There were ancient lakes on Mars. This is just a rendition of what one would look like on Mars. This is a crater that is filled with water. We think this may have been how the current crater that we're in with Curiosity, called Gale Crater, looked back about 3 to 4 billion years ago. So this is really ancient. And we have a lot of information that we're gathering on the Curiosity rover, in fact, that show us very nice details of materials that were laid down by moving water. In other words, a river was taking materials from out of the crater, bringing those materials down here and depositing them in layers, just like it does here on planet Earth. And we found ones that were coarser grained, that were probably deposited by rivers. And then we found some that were really fine grained, clay minerals, and clays, we call them, where they almost certainly deposited in the bottom of a lake. Now we know also that water is tied up in the soils and rocks on almost all the surface materials that we've looked at on Mars. This is one of those lake deposits where we looked at in Gale Crater, and we heated it up in one of our instruments. We were able to heat it up and sniff the gases that were driven off, and we were able to see about 2 weight % water tied up in those materials. So that could be a potential way to get water. Take regolith, take materials like this mudstone, put them into a reactor, a heater, drive that water off, and you can get water at the equator. So this is one way that we are looking at right now at NASA in order to extract water from the regolith. So now the question is, which of these options would not be a potential solution for humans to get water? Polar caps, permafrost, water from the upper Martian surface, water from ancient lakes, or extracted water from rocks and soils. So let's see how you do on this.
So again, which would not, in your opinion, be an option for potential water? So we'll see, and explain your answer if you have a few minutes to do that. So we'll stand by. So Gifford Middle School says 4, and we are interested too in knowing why you think that. So Meadow Creek says water from ancient lakes, however, some of that could be in the soil. So that's a good explanation of, yeah, probably not from ancient lakes because they're no longer there, but there could be water in that soil. Good explanation there, Meadow Creek. Let's see what else we get in our chat window. Mohansic says polar caps because it would be just too cold to be able to land up there. Thompson Middle School says 4, the ancient lakes because there's no more water there. Aerospace Academy in Mexico says extracted water from rocks and soil. Perhaps that would be challenging. Smith Elementary says extracted water, too much energy needed. Let's see. Peavine mentions the polar caps because it would be hard to get to and the water has not been analyzed to see what it is or what is in it. Synergy agrees with the polar caps as not being an option since it's a difficult area to land in and we could process the water from the remainder of those other locations mentioned. Gifford Middle School says there's no water there now, so not number 4. Good explanation. Meadow Creek says we don't have a way to get to the higher latitudes and bring it down, so it might be too much weight to deal with. Interesting. Peavine also adds in, we don't have a plan to get successfully to the north or southern areas. Thompson Middle School says the extracted water heated from the rock and the soils, they don't see as a potential solution. JCTMS adds in, ancient water has been gone for 3 billion years or so, so they're saying that's not a possibility. NMMSH says all options should be kept open. Murfreesboro in Illinois says number 1, polar caps, because it's too hard to get to and survive. Evansville Day School says none of these will give that much water. So Doug, with that, what do you think?
Well, I had anticipated that most of the answers would be 4 from ancient lakes because the water is no longer there and water is not stable at the surface. However, you're all starting to sound like a bunch of NASA managers now. And the reason I say that is many of you ask the same questions that our managers ask us. And the one that we're working on is extracting water from soils. And heating it up requires a lot of power. And they say, well, it's going to need too much power. We can't do that. So maybe that's the right answer. I'm not going to say that is wrong. And then the polar caps, well, you know, you might be absolutely right. It may be too cold for us to land there, set up a colony, and so the polar caps would be very difficult to live, but it would be really easy to extract the water because it's right at the surface. You would grab it, you would put it in some kind of device to heat it up if you didn't freeze up. So great answers there.
And Meadow Creek, Doug, by the way, also mentioned something about perchlorates, which I thought was very interesting, and that's a 6th grade group from Texas. So
outstanding. Yeah, and I'm not going to talk much about, in fact, I'm not going to talk all about perchlorates, but that's what I've spent my career in the last 5 years in, and I could spend 2 more of these talking about perchlorates. Perchlorates could be a real problem because it's something we're going to have to take out of the system. Perchlorates could be nasty for humans, so you're going to have to extract it out. And also, perchlorates are explosive, so we'll have to be really careful when we're dealing with anything that has perchlorates in it. So great answer. Okay, now the next question is breathable air, and how will humans get oxygen to breathe on Mars? And just remember that the atmosphere of Mars is only 1% of that of Earth, and it's 95% carbon dioxide.
So we want to know, how are you going to get oxygen to breathe on Mars? And again, we want your ideas because this is really getting you to think. So how are we going to get oxygen to breathe on Mars? Let's see what they come up with, and I'll read some of these answers out loud. Gifford says they can extract it from the CO2. Let's see what else we get. Kruger says from plants. Evansville Day School says breaking up the CO2. Dallas Arboretum mentions from plants. NMMSH says process from water and rocks. So getting that oxygen from the water and rocks. Smith Elementary says plants. Thompson Middle School says they can get oxygen from plants, water, soil, or even oxygen tanks. Murfreesboro mentions having lots of plants, so we need plants to eat, and maybe we can use them for some oxygen as well. Athens Intermediate also agrees plants. Mohansick Elementary School says bring seeds to grow trees and plants to extract that oxygen. Thompson says from the plants we grow. Synergy Quantum Academy says start a plant farm for the long term, and it saves on energy, and you can split the CO2. Peavine from Nevada says, can we permanently change the atmosphere of Mars? There's a question for you. JCTMS mentions oxygen tanks at first until the plants grow. So starting with something and then waiting for the utilization of other things. So I see a lot of plants there. Doug, what do you think?
Well, again, a bunch of fantastic answers, and if I had my way, I would grow plants too. I would process the soils, put it in a confined area, control its atmosphere, and grow plants, because that's a fantastic way to do it. However, NASA is thinking about a variety of ways, and this is just one of many. So there's no right answer to this one either, because there's a number of ways to extract oxygen, and just about all the ones that we're looking at were listed in the chat window. So great job on nailing all those. But one way to do it, of course, is by the reaction between humans and plants, just like here on planet Earth, where we produce carbon dioxide, the plants take our carbon dioxide with sunlight through a process called photosynthesis, creates that biomass within their tissues, and then expels oxygen so that we can then breathe that oxygen. So that's how we do it on planet Earth, and I think that's a great way to do it on planet Mars. Now, someone said from CO2, right now NASA is planning to initially extract oxygen in that way because it is in the atmosphere, as you said, carbon dioxide. We can take carbon dioxide, we can convert it into oxygen, and on an upcoming mission, and we launch in 2020, we will have an instrument on board that will take CO2 from the atmosphere, will process it by physical conditions, not by plants, but by energy, just heat it up, we do a few things to the CO2 to extract out the oxygen, and that oxygen will be used then for either breathable air or more than likely it'll be used as one of our elements for propulsion to help us get back off the planet with our crew members. So humans will need shelters. We heard this from a number of you when we asked the first question about what we needed on Mars, and shelters is going to be important. And the reason is, as many of you also stated, protection from radiation. We have right now on Mars, on Curiosity, an instrument that is measuring the radiation to the surface, and it's given us how much radiation a crew member would get. And just to give you an idea, there's about 500 times more radiation hitting the surface of Mars than hitting you today on planet Earth. That's a lot. So we are going to have to take protecting the humans from radiation very seriously when we get to Mars. Now, just going to give you some examples here. Those of you that saw the movie The Martian, you know how they were protected by these metal cans. NASA is looking at a variety of ways in order to put habitats on the surface and how to configure those habitats so that they would be very easy to live in and also protect us from the elements that we talked about earlier, the environmental conditions on Mars. Those of you correctly stated spacesuits. We will need a spacesuit to protect us, not only to protect us from the conditions outside, from the really low atmosphere, but also from the radiation. So we'll need that for our spacesuits and our vehicles that we drive around on the surface. And these are the ones from the Martian, and here are ones that NASA has built and are now testing to hopefully one day send to Mars. Now, look at this particular artist rendition. This is an artist did this of how a moon base might look. And you'll notice some really unique things here. Plants growing inside this, a really large chamber here, a tin can I call it, with a variety of levels. And you'll notice this encasing around it. And here's another one. This one here has this glass over it. And here we've created a little sub-Earth inside this particular area. This is probably not something we'll do immediately on Mars when we get there because this requires a lot of spacecraft to get materials down to the surface. But in a few hundred years, this could well be a way that we live on the red planet. Here you see a very different outer shell material here. So the question is, what is the difference between these two, and what would you have to consider in designing a habitat?
All right, so in the chat window, what do you notice that's different on that one on the bottom from that other one that is still shown there on the right? And let's see the types of answers that we'll have come in on that, on how it may be a little different. And Doug even alluded to a few things. Now, NMMSH mentions that the silicates are there to make glass. So whether that's a glass encasing there or some other type of inflatable, little challenging to be able to tell, but that is an interesting point that NMMSH is making there. We'll see what other things we get in there. We won't spend too much time on this because we're almost at 50 minutes past the hour, so we'll see what other quick things come in before we actually then move on to save some time for some questions. Now, Evansville wants to know who's mowing the grass, and the fact that there's even grass there that they have observed is great observation. Smith Elementary says the one on the bottom simulates living on Earth in a place where you can walk around and kind of enjoy the area. Thompson Middle School says one is a confined space, one is more open. Excellent. Thompson Middle School also says up in the corner it's more packed. The bigger one is more of a community and larger, more layers in the smaller one. The second view from Synergy Quantum Academy says it's certainly preferable giving sort of a park-like habitat rather than living in a can. And our NASA Solar System Ambassador is also looking at, you know, the whole idea of perhaps this would be something that we could do on the moon as a little bit of a trial. NMMSH also mentions that inflatables might be easy to start with. Athens Intermediate says it's a single city versus multiple. And Evansville Aerospace Academy in Mexico says in the left, the human and vegetable interaction is much closer. So there's many, many comparisons, and they brought up some really great observations there, Doug.
No, and absolutely, you've added some in here, and that's exactly why we asked this question, is to get you thinking about that. And the folks from Albuquerque at the New Mexico Museum of Space History probably have been dealing with a volcanologist there by the name of Larry Crumpler, who would be looking for a lava tube to put us in. So there are a variety of ways to protect us from the elements, particularly the radiation. So there's no right or wrong answer here, but you're identifying some of the constraints of what we will have to do when we get to Mars to build a habitat. So great answers. So now I'm not even going to ask this question and have you do the chats here. I'm just going to throw out this whole idea of power. This is pretty involved, but something on your own you might think about when you design your own habitat on Mars is how will you generate power? You know, solar, we do that with our rovers. We have a small radiothermal generator, a radioactive thermal generator on Curiosity. So there are ways in order to do that, to generate power. But when you're making your designs, think about how you're going to power your outpost, because this is incredibly important. So we are at the end of our time here, and I know most of you have to run off to other classes. But the thing I want to get across to you is that engineers are really important. That's absolutely correct for NASA, but it takes a whole lot of other people as well. It takes large teams working together, and for our rover missions and our lander missions, it takes not only the engineering team, but the science team to work very closely together to be successful. And but we're going to also need folks to keep us out of jail. We're going to need the lawyers, and some of you said the medical doctors. Absolutely going to have to send a medical doctor with us probably on those first missions to keep the crew gainfully happy and alive. But we need business administrators. We need farmers, as we have talked about, growing plants. So you have to have a lot of folks besides just engineers, scientists, and computer scientists involved in designing a mission to Mars. Now, in closing, I just want to, again, just solid education is absolutely essential if you want to work for NASA. So keep doing well in school and getting those good grades, and go on and get your degrees after you get out of high school in one of these fields, and maybe you one day can be working at NASA as well. And I'm going to finish by talking about my old college roommate. We met my freshman year at Colorado State University. We decided to room together. So for 3 years we roomed. The senior year, he was a great engineer, got good grades. He said he was going to join the Navy. He loved flying jets. So he joined the Navy. He went off and learned how to fly jets, learned how to land on aircraft carriers, was one of the best pilots they had. In fact, before the movie Top Gun became famous, he was the top pilot at Miramar, California at their test pilot school. So he was really a good pilot. And one day NASA called him up and says, hey, come to NASA, talk to us about being an astronaut. And he grew up in southern Colorado in a smaller town than I did, a place called Del Norte, Colorado. And his name is Kent Rominger. He's flown 5 times into space. He commanded the space shuttle 2 times, building the International Space Station. So from somebody from little school in southern Colorado, had big visions and big ideas, and it's amazing what you can do if you just set your mind to it. So with that, Paige, I'll be happy to answer questions for as long as folks want to ask.
Excellent. Well, thank you so much, Doug. And I know some of the groups out there are from real small rural towns. And, you know, like Doug said, if you've got the passion, the motivation, and the drive, you can really do anything. And so I know that we're a few minutes to the top of the hour. And as I mentioned in my email out to many of you, Doug is willing to stay on to answer questions for an additional 15 or 20 minutes or so. So if you're wanting to stay on the line to get some of your questions answered, please feel free. Since we're so close to the top of the hour, for those of you that do have to depart, I want to at least say thank you to all of you for joining us today. It's been great to hear and see your answers, and I especially want to make sure that I thank Doug for spending some of his time today with all of you, because he has provided some fantastic information, but you've also added to that fantastic information. So thank you, Doug. Thank you to all of you, and if you're able to stay on the line, we're going to start doing some Q&A. So right away, Doug, it looks like I got a question from Aerospace Academy. And actually, before we get to that question, for those that have to depart, Doug, did you have anything else you wanted to say before they do maybe disconnect?
Yeah, I just wanted to say and echo what Paige has said. Thank you for joining me today on this venture to another planet. It's really an honor to be able to sit in front of you all and talk about my favorite subjects, because what I'm trying to do is give you information to carry on, because you are the next generation. You're the ones going to Mars. You're the ones that are going to be the farmers and the geologists on Mars, not me. So I would love to see some folks that are involved right now in this telecon today be the ones that help us put humans on the Mars in 20 or 30 years. So thank you again, and I really enjoyed it.
Awesome. Well, thank you, Doug. And your passion is very, very evident. So hopefully that translates to those students as well. So Aerospace Academy from Mexico is wondering how any student from a foreign country could be part of a Mars crew for any potential Mars colonization, or become part of a NASA astronaut team. Any recommendations?
Yeah, so first of all, there are a number of astronauts currently involved in the International Space Station from other countries. Russia's heavily involved, Japan, Italy, France, Canada. They have all been sending astronauts to the International Space Station, so already involved. We have astronauts training at the Johnson Space Center right now, this very minute, from a number of different countries. So you can get involved and become a part of the program. There's not much, it's just going to take a lot of work on your part to be the best of the best in your country in order to go. I will say that when we send humans to Mars, it's going to be a very, very large program. It's not going to be just the United States. It's going to be Mexico, the United States, our European colleagues, our friends to the north in Canada. It's going to take the entire world working together to get humans to the surface of Mars. It's going to be an international endeavor. So almost certainly there will be folks from other countries that will be going to Mars. So there's always the opportunity for people that are not in the United States to be on that journey.
And just to add to that, I think, too, that we also had Jose Hernandez, if I'm not mistaken, who was an astronaut who is of Mexican descent. Now, I might have his first and last name incorrect, but you might check out Jose Hernandez if I have that correct. So, but thanks for that input there, Doug. Now, here's a question from Peavine Elementary. They're wondering, how does chemical engineering play into a mission to Mars?
Mm-hmm. Yeah, so big time. All of the wastewater regeneration, solid waste management, even the atmospheric regeneration, for example, the International Space Station, or on the spacecraft that will go to Mars, will take an enormous amount of input by a chemical engineer. You can well imagine that when you're converting carbon dioxide into oxygen, or you're taking wastewater and extracting out all of the things you don't want to drink, that is what a chemical engineer would do. So the chemical engineers are going to be part of the journey.
Yeah, and there's certainly a whole lot of specialized engineers that will certainly help out. Now, interesting question there. I'm going to kind of combine these two from Thompson Middle School and Dallas Arboretum. One is asking, will NASA take animals to Mars? And somewhat related to that, the other is asking about worms. Any thoughts about worms for the Martian soil? Somewhat related.
Yeah. So first of all, the animals. I advocated about 20 years ago, maybe even 30 years ago, when we were first designing the life support systems for the Moon and Mars, that we ought to take a pig. Now, a pig is a consumer of anything and everything. So all your solid waste, you just feed to the pig or a goat, and they would regenerate it back. But the engineers that were at that time would come back and say, well, now we got to keep the pig and the goat alive, and they're absolutely right. But let's put it this way. We are thinking about animals. Will they be part of the very first ones? Yeah, maybe not. Now, the worms is a really interesting one, because if we go to Mars, we would want to condition the soil so that it's Earth-like. And in order to do that, what better way to do it than with earthworms, right? So earthworms and maybe bacteria, folks were talking about bacteria adding to the soil. Those are really essential in a soil to make it much more feasible to grow plants in. So I think that maybe we will be taking earthworms and bacteria with us when we go and use Mars materials for growing plants.
Very interesting. Well, thanks, Doug. Now, here's another question from Mohansic Elementary School in Yorktown Heights, New York. They're wondering, when do you think is the soonest we can or might send humans to Mars?
Well, the soonest right now, the way that we are progressing with our launch capabilities, we have to build much larger rockets, and we're building those right now. We have targeted the mid-1930s, so 2030. So 2035 is probably a good guess right now. It could take longer. If the United States and the rest of our international partners decide to do it quicker, maybe it'll happen sooner. But it's going to take, I think, at least 20 more years before humans will venture to the red planet.
And so that could put some of these, especially younger students, right there in the midst of their careers when they will be an essential part of that. So
absolutely.
Absolutely is right. Now, from Thompson Middle School in Georgia, they are wondering, how is NASA planning on handling the dust on Mars in regards to food, shelter, oxygen, and travel?
Yeah, great question. In fact, we just convened a workshop at NASA this past year where we asked those very questions. And you can well imagine that in order to keep our breathable air in our habitats clean, we will want to make sure we have really good filter systems. So filters are really important. Also, you don't want to be breathing the dust. There was one, the question that was asked about water and things you have to worry about. Perchlorates came up, and if you have perchlorates tied up in the dust, which they do occur there, and you breathe a lot of that, it could be toxic. So we're going to have to be really careful to keep the dust out of our living systems, living areas.
Yeah, and that becomes a really important thing, especially in association with this next question from Mohansic Elementary School. They're wondering, and I think this pertains to the whole idea of dust, will the spacesuits have to be more advanced to go to Mars to protect from things like dust or being able to breathe as you're walking around on the surface?
Yeah, both. Absolutely. You'll need to keep that dust out of the inside of the spacesuit, and you can well imagine getting in and out of the spacesuit, and there's dust on the outside of the spacesuit. There are some ways you might be able to get in and out of that spacesuit without ever exposing yourself to that dust. So NASA has looked at ways of doing that. One way is to keep the spacesuit on the outside of the habitat all the time, and you simply crawl into the spacesuit from inside the habitat, and airlock closes behind you, and then off you go and do your thing. But we'll have to keep dust out of any moving parts. You can well imagine if a lot of dust got into the joints of our wheels and started grinding, there's just a lot of things we're going to have to worry about with dust. And of course, we'll have to potentially clean off some of the solar panels from time to time, if we have solar panels there, from dust to get our energy back up where we want it. So dust will have to be what we call mitigated. We're going to have to mitigate dust on the surface. It's a real concern.
Excellent. That's an excellent set of questions related to that. So we've got a question that comes back to you, and sort of, you talked about your schooling and where you went to college and such, but Athens Intermediate School is wondering, how many years did you actually go to school?
Well, besides the 12 years that you're going to go to school, I went 11 more. So my bachelor's degree, my master's degree, and then my PhD. And then I was a postdoc, which is actually not part of school per se, but it's still academic training. I went 2 more years, so you could say 13. So to get to my position that I am today, with my primary training and my post-secondary education, about almost 25 years.
And that might sound like a long time, but really when you're impassioned with what it is that you're doing and learning, and the more you want to learn and the more you want to advance yourself, you know, going to school and continuing to learn more. Learning is a never-ending process, and I'm sure even though Doug isn't officially going to school right now, I bet he learns new things every day. Is that right, Doug?
Every day. I learned when Mars Day was today.
Absolutely. November 4th, I think I got.
I did.
Awesome. And what's also interesting to those of you out there is that we have a wide range of folks that work here at the NASA Johnson Space Center who have, you know, varying degrees, from just an undergraduate degree to master's degree to PhDs. So it really does vary. And with experience and with motivation and passion and hard work, where you can take your career with or without that extended education it's all up to an individual and the hard work they want to put into it.
That's right.
So, Doug, here's a question from Kruger Elementary, and they're wondering, will NASA or would NASA ever consider looking at changing the atmosphere of Mars to sustain humans? Can you talk a little about that?
Yeah, great question. Scientists have looked at this question. Can we do something to Mars to make it hold its atmosphere? There are some really wild ideas. One of them is that you would explode a number of nuclear bombs in the atmosphere, creating a global monstrous dust cloud that would then heat up the surface, and maybe through time you could start creating somewhat of an atmosphere that might be breathable. The only thing is it would take hundreds of thousands of years to do that. To change a planet of that state would be very difficult to do. So we talk about it. Maybe someday we'll have technologies that'll be much grander than we have now. It would be a very difficult thing to do.
Well, and that's and is that even something that NASA doesn't quite necessarily want to change the environments on, even our own Earth or other worlds? We work with what we've got, but making a change like that would certainly be a challenge and something that might probably wouldn't happen.
No, in fact, NASA is trying to protect the planets. We actually have people that look at all of our spacecraft to make sure we are not taking nasty things with us on our robotic missions to the surface. So we are worried about not only bringing something back to Earth that might hurt us when we come back to Earth, but also what we take to the planet. We do not want to destroy a pristine environment like the surface of Mars.
Great way to put it. Thank you, Doug. Now, Mohansic Elementary School is wondering if there will be different types of food that will be brought out to Mars. Now, you showed some of the types of food you might want to grow, but might there be different types of food that will be brought out of Mars or out to Mars?
Yeah, so great question. Another one NASA has contemplated and had great debates about over the years. There are some NASA folks that say we could get all of our nutrients needed and sustain our health by taking pills. I'm not crazy about that. I want that nice, big, juicy tomato. So we'll probably have to take enough food with us to get to Mars. The question is, do we do something in Mars to grow food, for example, or produce food? That is something we are still trying to figure out. We do not have the answer to that yet. We will almost certainly take enough food for our first missions to make sure the crew will be happy for that entire mission. And a mission to Mars could take anywhere from a year and a half to 2 years to maybe 5 years. It depends on how you go to Mars and how you do it. We can only go to Mars every 2.5 years, so you're looking at a couple of years commitment, and that's a long time.
And that is a long time, although short time, but kind of a long time. And, Thompson Middle School has asked a question that you might have already answered, but let me read this and see what we've got. They're wondering how long would the individuals who go to Mars stay there, and would the structures be different sizes for them to live in?
Yeah, that's absolutely a very good question, because we do what we call trace studies at NASA. We say, okay, we can get to Mars in about 7, 8 months, maybe 9 or 10 or 11, depending on how you do the trajectory to get to Mars. Then you're on the surface for 30 days, or will we be on the surface for 500 days? Now, you got to make that decision, because you can get off of Mars, get back into Earth orbit, or Mars orbit, and get back to Earth, and it only takes a couple of years. If you commit to 500 years, you have to set a whole much more infrastructure, habitats, the capability to get around the surface, food. If we don't make our water there, we'll have to come up with ways to get water to the surface. That's a lot of infrastructure, mass, weight to the surface. So very good question, one that NASA has not even really decided upon yet.
Very interesting. So a lot of open questions out there.
Oh, absolutely.
Here's one that I have two. One is pretty short. One is from Mohansic Elementary, and they're wondering, is there lightning on Mars?
Yeah, good question. We think so. We think there is times when there's a bunch of dust in the atmosphere and things are blowing around. It develops an electrical difference between the surface and the material that's in the clouds on the dust, and you can actually have what we think are discharges or lightning. We think that potentially some of the chemicals that we see in the regolith or the soils could be formed by the interaction of lightning, for example, with chemicals such as chlorine. Maybe the chlorates are made that way. We don't know. They're nitrogen. There might be nitrates that are made that way. So there's a lot of things that could be going on at the surface that could be due to electrostatic discharging.
Very interesting. Now, also from Mohansic Elementary, this is an interesting question. They're wondering if you think that there's any type of organic life or living creatures that might be able to live on Mars without any special equipment.
Yeah, that's a great question. One of our main scientific objectives is to answer that question, particularly with the Curiosity rover and our upcoming mission, the Mars 2020 mission that's going to launch here in 2 years. We have on board instruments that are trying to see if there is any evidence of biological material, things that might suggest that life was once there. So we're looking at that. Knowing what we know about planet Earth, we find life in incredibly extreme environments. Very high temperatures, for example, well over the boiling point of water. Very cold temperatures, very deep in the earth. We see them in smokers in the bottom of the ocean, where these vents are coming up and some gases from the Earth's underneath the earth are coming up into the surface materials underneath the oceans. Lots of life there. So we think that those kinds of environments have been on Mars, so it could have been in the past conditions where bugs, organisms, microbes could have lived.
Excellent. And the search continues.
And the search continues.
And Doug, one of our last questions is wondering about, you mentioned some of these experiments that NASA does. Can you sort of summarize what is NASA doing to try to prepare for the human journey to Mars, or the future of our journey to Mars?
Yeah, yeah. So NASA is conducting a variety of tests where humans are, if you want to call them the guinea pigs, the crew members. We have ones where we put folks inside of, somebody said inflatables. We have an inflatable in one of our test areas that has been outfitted to be like it might be on Mars. And people will go in there and live for weeks to maybe even months at a time and see how they interact with the interior, see if they go crazy. The psychologists are watching them to make sure that that doesn't happen. We try to make it as mission-like as possible if they were going to Mars. We've also done tests, and I have been involved in these kinds of tests where I was a guinea pig, a crew member, where I lived inside of a chamber, a tin can, for 30 days, testing the life support system. So actually putting the carbon dioxide load, for example, on our life support systems to see if they could regenerate the carbon dioxide back into oxygen. We did this for the International Space Station, in fact. So we do have tests going on with humans in them continuously to help us one day get to Mars.
Awesome. And it's a challenge, and there's a lot of things to work on, and there's a lot of safety factors to make sure that it can be put in place. And so, but the generation of students that are on the line or have been on the line with us today are certainly the ones that are going to push that edge and get us there. And of course, they're going to get us there with some of that transfer of knowledge that you've been able to give to them, Doug. So as we are about 20 minutes past the top of the hour, I think I tried to get in as many of the questions, if not all of them, that came in through the chat window. So with that, I think, Doug, we're going to bring things to a close. We really appreciate your time, and we also appreciate your willingness, Doug, to do this this webinar twice, to be able to accommodate the large number of student groups that have a whole lot of interest in this topic and in hearing from you. So with that, thank you everyone who is still on the line. We hope you enjoyed our time with Doug Ming. And again, thank you, Doug Ming, for spending the time with us and sharing all this great information and passion.
Enjoyed doing it. Thank you.
Great. So with that, everyone, we'll officially come to a close. Thanks. Have a great rest of your spring, and we look forward to connecting with you again sometime in the future. Thanks, everyone. Bye-bye. And with that, Doug, we'll call it a day. Thank you again so much for doing this today, and I'll touch base with you sometime in the next couple of days.
Yep, I'll be